So we are going to talk about the LTE Advanced, which is real 4G, and I don't know, it is probably already almost here. So we will talk about the requirements and what are the new technologies. The purpose of teaching you about LTE and LTE Advanced is to just tell you what is the latest in wireless. Okay, so we'll see some more latest stuff in wireless. And that is carrier aggregation, coordinated multi-point operation, small cells, inter-cell interference. Coordination. This is a repeat of the previous lecture. 4G. 4G is actually IMT-Advanced. This should be just in your brain now, right? Requirements are very clearly specified. That it should be IT based, that it should provide 1 gigabit, that should provide 100 megabit, that it should provide 15 bits per hertz, 15 bits per second per hertz, and 6.7 bits in the uplink. And the edge of the network it should be at least this much, and on this overall cell we should get 2.2 bits per hertz. Seamless connectivity, global roaming, multimedia, and so on and so forth. There are two technologies which satisfy this: LTE Advanced and WiMAX Release 2. Okay, they both have been approved as satisfying. So LTE Advanced. Now that we remember that those requirements, LTE's goal is to meet or exceed IMT Advanced. So we just don't want to meet, because if we just meet, maybe we might lose, because in some tests we may not come out. So they said we want to exceed. 3 gigabits downlink. All right. Requirement is 1 gigabit, but we can do 3 with 100 megahertz. And 1500, 3 times, instead of 500, we can do 3 times. It should be 1,5. So basically 1500 megabits, not 1.5 megabits. Okay? In the mobility situations. Spectral efficiency up to 30 bits. Remember, this is corresponding to 15 bits. Using 8x8 MIMO in the downlink. And 15 bits using 4x4 MIMO. So we can do whatever they want with, they required here 15 with 4x4, but we can also do 8x8. Cell spectral efficiency 3.7. This was 2.2 before in the previous picture, and 2.4 and 2.6 depending upon how many MIMOs we have. Edge efficiency is again better. Okay, so the key thing here is that depending upon the MIMO we can do better. Latency less than 10 milliseconds from dormant to active, and less than 50 milliseconds from CAM to active. So basically it should be totally invisible. Mobility up to 500 kilometers per hour. Spectral flexibility, etc. is as before. And somehow be able to use 100 megahertz channels. So this is the latest. Now, one key mantra of wireless design is that if you want to get data rate, there are three needs you play with. Band, spectrum, which includes two things, band and the bandwidth. So basically, if you run at 700 megahertz, you get a different result than if you run at 2.4 gigahertz. You know that, right? And then the spectrum, if you use 100 megahertz, then 50 megahertz, you get different results. So if you want really high data rate, you need really big band. Then the second thing is spectral efficiency. Now suppose you did get 100 megahertz or 50 megahertz, then the second thing you play with is spectral efficiency. How can we get the maximum bits per second out of these hertz? Right? And for that we have coding, we have retransmissions, we have a lot of games to play. And the third thing we play with is this space, cell size. If you really need high data rate, make the cell smaller. The smaller you make, more bits per second you will get. All right. So we will. That's what basically what what LTE Advanced does. First thing is the bandwidth. So 100 megahertz was never heard of before, but now we can use 100 megahertz. Remember, 3G was 5 megahertz. So we can use 20 times more right there. And spectral efficiency, what do we do? First of all, we have a frequency reuse factor of 1, so you can't do any better. Maybe tomorrow they will discover frequency reuse factor of 0.5. I don't know, but right now 1 means you use the same frequency everywhere in every cell. Higher order MIMOs, and we keep going up in MIMO, 8.8 times 8 in downlink and 4 times 4 in uplink. New MIMO techniques, single user uplink MIMO, and then inter-cell interference, coordination, and cancellation. So if we are going to use the same frequency in every cell, clearly there is going to be a problem. It's like this. If we all start speaking the same language at the same time in the same room, there's going to be a problem, right? So what we have to do is we have to do some kind of interference cancellation. So we have to say, okay, all right. You just, for this little time, you don't do this thing, and I will do this thing, and then maybe we will be happy. So there are techniques that we'll talk about. Cell sizes. Now the cell sizes are not the same as before. Now we have something different called relays and small cells. So we'll see that. So first thing, how do you get 100 megahertz? There is no spectrum where you can get 100 megahertz. Not even at 2.4 gigahertz, not at 5.8 gigahertz. Everywhere the things are much smaller. So how do you get 100? You get 100 by combining many little pieces. And that is called carrier aggregation. So carrier aggregation means that you can take, I am calling it bands because I find it easier to say band and the bandwidth, but the real term is component carriers. So we will use the word carriers because we also have subcarriers. Subcarriers are those 1024 that we do in FFT, but here they are carriers. So carrier aggregation means we take 1, 2, 3, 4, 5, up to 5 bands and then treat them as one. Same thing in the uplink. Okay. Now this is backward compatible with LTE. So an LTE phone should work in LTE Advanced. Right. So what happens is basically each of these carriers, a phone will not be able to listen to 5 carriers, it will be able to listen to one of them. Right. And whichever it listens, it should be able to just work with that one and done. So that is backward compatible. So the old phones which are single carrier will work with this multi-carrier stuff. Because each band is exactly as it was before, which is 1.4, 3 megahertz, 5 megahertz, 10 megahertz, or 20 megahertz. This was the width that was allowed in LTE. Now you can combine 5 of 20, then you get 100. But you can also combine 1.4 with 3 and 5 and 10 and 20, and that will be, much less. It will be 35, 38, 39.4 megahertz. So anything you can combine with anything. Okay, it is not necessary that all 5 be same width. So if you had some old spectrum which you were not using, and then you got some new spectrum here, and then you got new spectrum there, you can combine all of that, aggregate all of that into one. Okay. Maximum 5. Each component can be different width. Number of components and the DL and UL can be different. So you may be able to receive 3 but not transmit 3. Yeah.
Why is maximum 5?
Oh, because we need 100. And actually even 5 is difficult. So the way 5 is coming in is that they have releases in 3GPP. So release 8 is LTE. Now they are to release 12. So 9 will have 2, 9, 10 will have some more number, 3 will have, so every release adds more complexity. You understand? So basically 5 is a large number, believe it. Because I don't think, I remember in Zymax days, we talked about 5. 2, 3, 4. 5 is an upper end right now. It's like a MIMO, wide and limit of 8. I mean, putting 8 antenna looks like, you just, let's exhaust the space and exhaust the circuitry required for it. At least today, right? Tomorrow we may have better antennas or maybe better computing power. So 5 is physical, actually complexity limit currently. All right, so it can be different, but number in DL should always be more than number in UL. So if you are going to send 4, the base station has to be able to send 4 too, minimum. I mean, base station is generally more powerful than the mobile. So if the base station cannot send 4, you cannot send 4. That's all that rule says. Components can be contiguous like this or non-contiguous like that. They can be at different power levels, and therefore each has a different cell size. You see, blue has a lot of power and therefore it can go farther. Yeah.
You mentioned that you're scraping together individual carriers. So once you take a particular type of carrier, don't you have to use that for each and every cell, which makes it difficult?
No, hold on. So this is, okay. So your question is, if I selected the blue, shouldn't I just use blue in all the cells? No, the answer is no. When you change the base station, you change everything. When the mobile moves from St. Louis to Kansas, who knows what you get there in Kansas? Okay. So yes, when you are here, say in this picture, you might be using green. And then you come here, you cannot use green, you will be using blue, even though it's attached to the same base station. So that's another thing, is that if you were able to receive all 3, which, basically in this case, if you receive only 1, then you will receive green here. Right? So each carrier has a different cell size. And you always hang on to the highest, or what they call strongest signal with the least interference, right? So in this case, if you are here, you will hang on to either green or blue. Here there is no choice, blue. Here, red, green or blue, but most likely you will hang on to red. Actually, hold on. Not you. You can hang on to red, green or blue, but the base station will most likely give you red because, it has other people to serve in the blue areas and so on and so forth. It will decide how to give it, what to give it to you. Size, MAC, Phi and RLC are all extended. So now everything is extended to include component carrier. So in the headers we saw before, they didn't have component carrier. Now they will say, okay, please go to the red, please go to the blue, or whatever number that is. And your transmission is in the red, yours is in the blue, yours is in this color. Okay, so everything has been extended. And I'm not going to go through that complication. But if you need to work in this area, then you will find in the specs all the details. I think that is all I have for carrier aggregation. Any question about carrier aggregation? If not, then we go to MIMO. So MIMO is used only when SINR is high. What is SINR? Signal to interference noise ratio. When SINR is high means the signal is high and the interference is low. Right? When you are in a good shape, then use MIMO. So in this picture, where is in good shape? Who would be in the good shape? In the red circle, green circle, or in the blue circle? Red, because here there is a strong signal. Obviously interference from other places would be much less, whereas in the blue the signal would be smaller and the interference would be very high. So SNI, so here you won't be able to use MIMO much. Here you can.
Does those reds interfere with blue and green?
Of course not. It's like this. 2.4, does 2.4 gig interfere with 5.8? Yes, you have really bad design. Alright? So, MIMO is used only when SINR is high. That means the channel is good. If SNRI is high, then other techniques will be used, which like transmit diversity. We discussed that in LTE. So those will be used, but not MIMO. Many different transmission modes have been defined, and UE is informed about the mode to use by signaling. So basically, there are many transmission modes that say, okay, please use 2x2 MIMO with this kind of coding, this and that. So, there is a number for each of those, and UE is the user element. So the user is told about that. Modes differ in the number of antennas, the antenna port, pre-coding type, and the type of reference signal. So when you use a particular mode, then you know a particular antenna, a port on that antenna, a pre-coding type, and I'm going to define the pre-coding type in the next slide, and the type of the reference signal. We have already seen reference means pilot, type of the pilot. So it will be told that, this is the pilot pattern, that you have to use, we are going to use. And so there are 3 new categories of UE. So now when the phone comes on, he says, I'm category 6. That means I understand LTE Advanced. LTE guy will say I'm a category 5. And some older guy will say some other category. Alright, so every UE has a category which indicates how much they understand, how educated they are. And so this is LTE Advanced is 6, 7, and 8. Category 8 supports the maximum feature. So the best, most expensive category is 8. Pre-coding. So there are 2 pre-coding, and what is pre-coding? Basically, you remember DFT pre-coding, that was single carrier FDMA. When we discussed single carrier FDMA, what we did was we took the symbols and then we did some coding before we put it there, right? So that is where the pre-coding word comes from. Now we can use that here. Either we use a codebook based pre-coding. So codebook based means there is a table which everybody has from the standard. Everybody has. So we can say, okay, so please use the row number 15. Okay, that is called codebook based pre-coding. In that case, we use cell reference signal. We use the pilots that are common throughout the cell. Cell reference signal. Reference means pilot signal. Cell-based pilot signal. Second one is non-codebook based pre-coding. So there is no table, and we use demodulation reference signal are added, and so this is basically a very specific to the user. And so basically this is a pilots are used which are very specific, and they are added before pre-coding. So basically let me show you this picture. So this is the first one, codebook based. You get the data and you did whatever pre-coding, but then you add the pilots here, and then you do the DFT or whatever, etc., FFT, IFFT, etc. They go to the receiver from multiple antennas. If you want to do this one, non-codebook based, you add the pilots, and then you do whatever you need to do. So when it is received here, it is exactly the same way. But the idea here is that now it is very specific to the user, and so there is no table here, and so this has to be used when you want to somehow, this one says UE specific, means that these signals are very specific to the user, whereas these are cell specific. These are not specific to the user. Everybody gets the same signal, same pilots at the same place. So just by playing with the location of the pilots, we can somehow help out in the MIMO business. This is all to help MIMO, so that you can figure out which signal I'm getting, which antenna, where it's coming from, where it is going. Again, to summarize this, basically we need to know where the signal is coming from and going. So we do this two codings. One is codebook based, where you look at a table and you know exactly where the signals, pilot signals are. And second is non-codebook based, where we have some very specific to the user. All right. Third thing is coordinated multi-point operation. Any question about pre-coding? Basically adding the pilot signals. Then we have COMT. And since we are using the same frequency all over, the people who are at the edge are in trouble because they are getting interference from the other side. But good thing is that the base stations can talk. And the mobile can say, well, I am getting interference from base station number red. And so then the base station blue can talk to the red and say, please don't speak in slot 1 carrier group 3. A particular resource block. In that resource block, I really need to talk to this guy.